Very good.
Thank you very much. Yes, I'm also happy to be here and talk a little bit about Fraunhofer Chile. I will share my screen. There it is. And yes. So hopefully everybody can see my screen.
Yes.
Very good. So today we talk about green hydrogen and concentrating solar power and the benefits and perspectives for mass production. And first, a few words about Fraunhofer Chile. We are an applied research and development center in Santiago de Chile, and we are looking for solutions of decarbonization of the industry. We transfer technology and expertise from Germany, being part of the Fraunhofer Gesellschaft network, and Fraunhofer Gesellschaft, probably you know, is the world leader in innovation in strategic sectors for the economy and society. Our solar energy center now exists 10 years, therefore also the 10 years advertisement at the beginning. And we are a center of excellence funded by the Chilean government with the base funding and also by Fraunhofer Gesellschaft. We have in the last 10 years implemented more than 130 projects, and we are working very closely together with Fraunhofer ISE, which is our parent company, which is the biggest solar institute for applied research in Europe. Our center in Santiago de Chile is working on 3 different activities. We are working on photovoltaics, we are working on solar thermal systems, and we have a department for new technologies where we do economic models, electromobility, and also synthetic fuels by green hydrogen. And with this, we started at the beginning, and now we are working more and more in green hydrogen. And therefore, I also wanted to give this speech. Just a few pictures from our team. Here, this is Fraunhofer Chile. We have a extended management team. We have different teams. In Fraunhofer, we are about 30 people, and you see most of them look quite happy. Now let's come to the main topic, CSP and the future of green hydrogen. And you can see on the right, this is our solar tower in the Atacama Desert. Its name is Cerro Dominador, and it's a 110 megawatt solar thermal power plant with a big storage of more than 17 hours. And in the back of the photo on the right side, you can see the photovoltaic plant, which is also 100 megawatt. So this is a real nice hybrid solar, 100% solar, but a hybrid plant with photovoltaics and also with CSP. When we talk about green hydrogen, especially in Chile, we can see that this is key for the energy transition. And we have a lot of emissions in Chile by producing energy. Of course, we have coal-fired power stations, but also the industry is using a lot. In the south, we need also heating for the residentials. And with all this, there's a big demand on energy. And of course, the transport sector, and not only the electrical sector. And we have this, hydrogen plays a crucial role in the decarbonization of the sectors, which cannot be electrified. And this is not only in Chile like this is all over the world. And therefore, hydrogen has a big potential for being used. It's an efficient way to transport green energy over long distances. And we have the flexibility of use because it can be used almost for everything. You can produce electricity again, or you use it in chemical industry or in steel industry. So hydrogen is really something great, and you have to look where you can produce it for low costs. And hydrogen also allows to export energy, for example, from Chile, where a lot of renewable energies are producing cheap electricity in the form of derivatives like ammonia, methanol, dimethyl ether, or others. Here is the Chilean hydrogen map, where you can see how much hydrogen should be used in the future. And this is the green path here. Of course, we have the uh, renewable energies. We also will work on the efficiency to reduce emissions. But green hydrogen has almost a quarter of the whole possibility. And because Chile is a very long country, it's not big, but it's a very long country. In the south, we have a lot of forests. So the gray part is capturing CO2 from the forests. We are looking for being 100% green by 2050 in Chile, and Chile wants to become the world leader in production and export of green hydrogen. And they have really the chance for it. And Chile has the potential to produce green hydrogen at low costs due to its abundance of renewable energy. So there is big desert in the north where the sun is shining best all over the world, and we have very strong winds in the south, which is also a good place for producing hydrogen. Probably you know the Power-to-X routes, and you see at the beginning on the left side the sustainable feedstock. We have wind energy, solar power, hydropower, and of course we need to produce Power-to-X and the synthetic fuels. We also need CO2. And this could come from the air, or it could come from industry or biomass plants. And with this, we are producing methanol. First, of course, hydrogen by electricity, and then methanol or ammoniac and ammonia. And then we have the different possibilities for end products like fuels, energy carrier, like using the hydrogen or the methanol in the chemical industry, or also the ammonia for fertilizer and energy carrier. And then, of course, it's quite efficient to transport the hydrogen in the form of synthetic fuels. Fraunhofer ISE did a lot of modeling for the H2 Global group, and especially they were looking at levelized costs for renewable electricity, and also how many full load hours for the electrolyzers could be offered. And with this, many different countries in the north of Africa and also in South America were looked at by H2 Global. Unfortunately, Chile was not looked at. We don't know why. They were not on the list of H2 Global, but we try to do this study now in Chile by Fraunhofer Chile, of course, together with Fraunhofer ISE to do this evaluation too. Well, when we talk about green hydrogen, what are the main challenges? Large-scale green hydrogen production at the moment is not very cheap. There are still high production costs, and this depends, of course, of the big energy consumption the electrolyzers have. And with this, the price of the electricity, of the green electricity, is very important. The constant, and also it would be good to have a constant energy source, because the electrolyzers have constant energy demand for providing a stable supply of 24/7 production. In Chile, on the left side, we have one demonstration plant which is installed. There's just one windmill, and they produce methanol, and from this methanol, they produce synthetic fuels, especially for Porsche, which so they already have their off-taker, and it seems that this plant is running quite well, because the last Porsche Cup, I think it was in Great Britain, was provided by them with synthetic fuels. On the right side, you can see a photo of the Chilean desert in the north of Chile, and there's plenty of sun. This is really the best place for solar energy in the world. So, coming back to CSP and the opportunities for hydrogen production, first, I would like to say concentrating solar power is one of the world-leading alternatives for 24/7 electricity generation. And this is why CSP has an integrated solar thermal storage tank. And with this, for all countries with high direct radiation, and direct radiation can be focused, and that is what you can see here. There's a big solar field with mirrors which are reflecting the sun to the top of the tower. And there in the receiver, here we can see this in this picture, that the sun is reflected on top of the tower. And we have a two-tank system. So we have a cold tank, and the cold liquid is pumped up to the receiver, is heated up to more than 500 degrees here, and then goes back into the hot tank. And this is the loop which is running during daytime, and in the afternoon, when the sun goes down, we can get energy from the hot tank for producing steam. And this runs a steam turbine and a generator. And as long as the hot tank has some liquid, you can produce electricity with this plant during daytime and also during nighttime. And this is something which makes this kind of technology so unique, because with photovoltaics and batteries, you need also much larger solar field with photovoltaics, and also you need batteries which can cover the electricity supply during the night. And therefore, we think, and we prove this with several studies, that the 24-hour production with a CSP plant is much cheaper than photovoltaics with batteries. Here, this is the view from one of the towers down to the storage system. So you can see the hot tank and the cold tank just side by side. And here's some heat exchangers to produce steam. This offers multiple applications, providing both direct thermal energy, which also can be used, and we will come to this later, and also the electricity generation. The CSP acts really as an ideal complement for managing thermal energy generation from renewable sources. And the 24 hours 7 production in operation, the solar field needs to be 2 or 3 times bigger because you have to fill the storage system during daytime and also produce from the hot storage system during nighttime. And therefore, we talk about solar multiple, and the solar multiple for a CSP plant which runs 24/7 has always a solar multiple of 2.5 to 3, and also has a storage system which has at least 12 hours of storage capacity, full capacity of the power plant. Here you can see how a hybrid PV and CSP system will work. So during daytime, we have the generation, and this is a little bit moved. It's not PV generation up to 24 hours. 24 hours should be here. Sorry for that. But that happens. So this is the morning at 8, and here we are at 8 o'clock in the afternoon or at 6 o'clock in the afternoon. And just around it, you can see that the CSP plant can deliver the electricity you need. I talk now about towers, but parabolic trough technology is already proven since the 80s by the World Bank. And there are a lot of plants all over the world installed, and they work similar to this scheme. We have the solar field, we have the storage system here, and we have a heat exchanger for the storage system. And then we have also the possibility to produce steam. And we have the steam cycle here. And the big advantage of CSP is that you can directly use the energy coming from the solar field, or you have the energy which you can put into the storage system. And with this, you always have flexible and predictable electricity production to meet the demand. There are some other possibilities to shift energy or to balance energy, which is shown in this slide. Sorry for this noise in my back. There is also CSP with thermic storage, which can be used for the regulation of the grid and also for power quality. Yeah, and when you install a CSP plant, also more flexible systems like photovoltaic and wind can be installed, because the CSP plant gives a really great inertia to the grid. So hydrogen is, and its derivatives, production is highly energy intensive, and the demand of CSP, or with the CSP, we can boost the efficiency, and also we do a lot of hybrid plant configurations where CSP could work together with photovoltaics or even with wind. Here, one of Fraunhofer ISE's examples, they did a study. It was Shakib et al. Here's the manuscript. It's still in preparation, so it's not published yet, but they gave this slide to me where they did a study with CSP, PV, and wind, and they did PEM electrolyzers, seawater desalination, and they produced methanol, ammoniac, and so with direct air capture, and they could reduce the levelized production costs for power to X. And I think this is one thing where CSP really has a good chance in areas of a lot of direct radiation. Here's some results. In this picture, the energy production from PV, CSP, and wind for the methanol synthesis is shown. And you can see the CSP always works during nighttime. Photovoltaics works during daytime. And even if you run the electrolyzers only on half of the power, it's quite a good possibility to use it. Then I got a slide from IKTS, Fraunhofer IKTS, and they do coupling with external heat sources. And here you see on the left side, if we just do low temperature electrolysis, we can produce 110 cubic meters per megawatt hour of heat. But if we go for a high temperature electrolyzer, then we can even produce more, and almost 20% more. And this is something where CSP also will have a possibility to be used. Here, it's also just producing electricity from a CSP plant for low electrolyzers. But if you do not only use electricity, you will lose less electricity, but you also have the heat, and the efficiency of the electrolyzer is much higher, and therefore you also increase the production of hydrogen. So heat for water evaporation is needed, and therefore, of course, it could be industrial waste heat, but it could be also heat from a CSP plant. And the application of high temperature electrolysis allows to produce more hydrogen with the same amount of thermal energy. And I think these are really nice options we can look at. Just to give you an idea how many plants of CSP exist, Spain is the biggest, is the country with the biggest installed capacity, 2.3 gigawatt. And so there are almost 50 plants in operation in Spain, and 70 of them have thermal storage, which are parabolic troughs with 7.5 hours of storage. And there's one tower with 15 hours of storage. And you see the capacity together, and they're all running. And so Spain is the country with most of CSP. And you see it's southern Spain where the radiation, the direct normal radiation is quite good. And in Santiago, we have a similar radiation as in the best place in southern Spain. So going to the north, we have up to 50 or even more than 50% better radiation in the north of Chile than in Europe. This is a photo which shows Andasol 3. I worked at Andasol 3 as the technical director for the construction time and also for short operational time before I went to South Africa to do more CSP. And here you can see the parabolic trough solar fields. On the left side, we have the big salt tank, which a diameter of 36 meters, and the tubes where the heat transfer fluid is running. And here in the back, you can see the cooling towers, the water preparation tank, and so on. Well, let's come to the conclusions. From my perspective, CSP can be key to large-scale green hydrogen production, especially in regions with high solar radiation. Its thermal storage capabilities ensures 24/7 electricity generation, providing grid stability and enable continuous hydrogen production. However, the most efficient solution does not lie in a single technology, but rather in an intelligent integration of systems. And as you have seen, heat integration from CSP can reduce costs, and hybrid models that combine CSP with sources such as photovoltaic offer flexible optimize the use of local renewable resources and diversify project risks. The continuous supply capability is essential for enhancing the competitiveness of hydrogen production, which is highly energy intensive. Sorry for the last sentence. I normally speak Spanish and not so much English because I'm already 8 years in Chile now. Therefore, talk German, or I hope you could get all my English. And thank you very much. And do you have any questions?
Thank you very much, Dr. Dinter, for your presentation. Very well-rounded and interesting talk on CSP. And yeah, I'm looking forward as well to all the questions from our participants. We already have one question written here by Ashish in the chat. And I also encourage everyone to write their questions in the chat, or maybe they can raise their hands and we can go by one, by like if they want to say their questions directly to us. You can simply raise your hand and then unmute yourself. But let me read the question here from Ashish. He's asking, or she, on the area required for CSP. One second. For CSP, is it more compared to PV plus battery, or is it less?
Well, yes. In this case, when you have a photovoltaic plant, you can provide about 1/3 of electricity of a CSP plant with the same capacity, and with the same capacity. Yes. And with this, if you want to install 100% and want 24-hour production, you need 3 times of the solar field, and you need twice the battery system. So the battery system does not need much space, but you need 3 times the photovoltaic plant. So you don't need 100 megawatt, you need 300 megawatt of photovoltaics. And then you need not 100 megawatt of storage system, you need 200 megawatt of storage system to have the capacity for the whole hours. And with this, of course, the CSP plant needs more space than a photovoltaic plant. But in very sunny areas, you normally have enough space because it's mainly desert, and so there's no issue.
Thank you. I hope that if you have any follow-up question, Ashish, please feel free to answer it, to ask it. We also have here a comment and a question from Asha. Thank you for the nice presentation. How will Chile address its electricity transmission issues from the north to the central region?
Yes, somebody knows exactly what are the problems in our country. There is a high voltage transmission line, which has a capacity of 2.2 gigawatt, and already 7 gigawatt of renewable energy is connected. So this is really the bottleneck we have from the north to the central area. And by 2030, there should be another high voltage line in parallel to this. And of course, decentralized electricity production is one of the topics we discuss in Chile. And also next to Santiago, we can build some CSP plants because the sun is still shining much better than in Europe. So, and we have so many plants already in Spain. The thing is, you need, or yeah, as higher the radiation is, the cheaper is also the electricity you are producing. But we made some studies for building CSP plants next to Santiago, in the north of Santiago, where the radiation is 2,400 kilowatt per square meter and year, where we even could produce for the same price as the current price from coal-fired power plants is. So
Hmm.
up to there, no problem, and hopefully we are continuing soon with building new power stations.
Thank you. We have plenty of questions here. Um, I think I will not be able to read them a lot, like depending on the topic. So
Mhm.
excuse me for that. I won't be able to, but I will read them just in order. The second question is if we can talk about the cost of CSP and what are the challenges of operating CSP?
Yeah, um, the solar tower plants, most of them had problems with the hot tank system, with the hot salt, and it was a kind of engineering and construction failure, which was done at least by all Western solar towers. The Chinese don't have any problems with this, so they use another technology or maybe other material but they said they have really no issues, and the country with which is continuing installing CSP plants is China.
Mhm.
And so in the Western area, like Europe, like the United States or South America, we have less activities with the CSP. There's one plant in under construction, which is now in commissioning phase in South Africa. This is also a tower, and we hope that they have learned the lessons, and this tower will work properly. So there was a kind of gap of investors for CSP plants because they said this technology is not ready for being commercial. But finally, most of the problems are solved, and also the CSP plant in Chile had this problem with a hot tank. They are now installing new hot tanks. And with this, the plant is hopefully will run again in December and will show their performance. And then hopefully it will continue with CSP plants because from my perspective, the technology is really great. And it's the only one which can 24-hour produce electricity beside hydropower power stations. And also, if you talk to PV and battery guys, they normally say this is much too expensive to produce 24 hours. Batteries are made for 4 hours or for decentralized systems, but they are not for large-scale power production.
Um, we have here a more technical question on why not use the heat of the CSP to directly produce hydrogen via a thermochemical separation process? A question from Elisa.
Yes. We some some research institutes do this, but on the other hand, you can use it normally only when the sun is shining. So you have to cool
Mhm.
down the process and you have to heat up the process every day. And yes, it's possible, and maybe it's something for the future. We
Mhm.
are also doing some research on that in Chile, together with the University of Santa Maria. But in this case, you always have to heat up in the morning and you lose a lot of time, and therefore it's not a constant production. So this is a niche, and let's see how this niche will develop. Yes.
Right, thank you very much. Here also a question from Idowu on what is the average DNI required to validate investment in CSP?
What is
There
the?
are the average DNI, so this the radiation
Yes,
that
yes.
was mentioned
Um,
earlier to validate
well,
investment.
yes. Well, in Spain, the best place has 2,150 or 50 kilowatt hours per square meter and year. In Santiago, we have 2,300.
Mhm.
And if you go to the north, you have up to 3,500 kilowatt hours per square meter and year. And this is something which is really, really high. In South
Mhm.
Africa, in the north, in the Kalahari, you have also 3,100 kilowatt hours per square meter and year. Namibia is also a very nice place for CSP plants because they
Mhm.
have also a very high radiation, almost as high as in Chile.
Yeah, so plenty of opportunities and
Yeah.
possibilities for CSP in the
Mhm.
future. One more question here on whether it has the same lifetime span as UV, which is around 20 to 25 years.
Yeah, no, it has a much longer lifetime.
Yeah.
So
Mhm.
a normal power plant with the turbine and all this steam generator and so on has a lifetime of 40 to 60 years. And the CSP plant, which we built, like Andersol 3, where I was the technical director, was also built for at least 40 years. And with this, it's almost the double of a PV plant. And
Mhm.
the recycling is also probably easier because it's just mirrors steel and concrete.
Mhm.
So there are no other materials which you use. For example, the molten salt, which is used as heat transfer fluid, can be used again and again and again. There's no degeneration of the material. And with this,
Mhm.
also the heat transfer fluid could be even used in a second plant if you want.
I think it also justifies the high cost in a way as well because
Yeah.
it lasts for longer. One question here as well from Irfan. Hello, sir. Very informative presentation. Can you please let us know if there is opening in all right. Okay. I didn't read it before, but basically, if there are any postdoctoral positions in Fraunhofer, Chile.
Yes, we like to have people from Europe or from all over the world in our offices. At the moment, we are four Germans and one from Italy. We are looking for always for good people. Um,
Mhm.
w- Mainly, we are funded by projects. And so if there are projects, we also offer jobs on our website. Uh, Postdocs are always welcome, but we have to look for funding for the postdocs. So at the moment, we have two postdocs, one in agrivoltaic and another one in hydrogen, but they run out end of the year. And
Mhm.
of course, if there are possibilities and even to bring some funding to Chile, then we always have work.
Okay,
And
so
we're looking for good people.
perfect. So best thing is to keep an eye also on the website to see if there are any new projects coming up alongside
Yes.
any job opportunities.
Yeah.
Thank you very much for your answer. Do we have any final questions from participants before we end our session for today? Okay. Oh, one last question, let's say, before we wrap up our session from Ross. In light of Iberian blackout, is Chile installing batteries? Batteries provide some system services than CSP.
Yes, of course. When we had the blackout in February, similar to the Spanish blackout,
I wasn't
um,
aware of that.
Ye-
Interesting.
Yes, we
Mm-hmm.
were almost one day out of electricity,
Mm-hmm.
and there was a mistake in the transport grid, and there were some fluctuations in frequency. And if you have fluctuation in frequency, normally the inverters for photovoltaic plants shut down or cut the connection because of they want to save their PV plant or their wind plant. And with this, you have the big issue that there's a lot of demand, but there's no electricity production anymore. And that also happens when France shut off the grid, or there's 3 to 5% of electricity production in the north of Spain coming from France. And France had some problems, and so they cut the connection to Spain. And with this, also they had this frequency jumping up and going down, and all the inverters shut off. And if you
Mm-hmm.
cut off all the renewable energy production for in a short moment, then of course there's no possibility to have the backup systems running. And therefore, they are now installing batteries. But if they install batteries with the same wrong inverters and not with intelligent inverters, we will have the same problem with the next blackout and or with the next grid problem. So
Mm-hmm.
it's very important to install the intelligent inverters, which are also managing the frequency. And if we don't do this, and all the Spanish plants which were installed are old plants, photovoltaic plants with old inverters and not with intelligent inverters. And even intelligent inverters are more expensive. But we have to go for these intelligent inverters to keep the grid stable. That is my message I have to give after these blackouts we had.
Yeah, definitely. It makes sense as well, even though it will be a higher cost, but I think it will prevent another catastrophe like that or a blackout like that. All right. I think we had our last question. Thank you very much to all our participants for taking part in the talk and also for your engagement and for asking all these interesting questions. Like I said, you will find the recording in our YouTube channel. And yeah, thank you very much, Dr. Dinta, for this wonderful presentation and also for answering all of our questions. Yeah, it was a pleasure to have you. And I invite all our participants to go to the next talk. You have here the link directly to our next talk as well on creating an energy map to assess green hydrogen in Kenya. Perfect.
Thank you.
Thank you.
Thank you very much for having me. Bye
It
bye.
was a pleasure. Bye. Have a nice afternoon.
Thanks.
Goodbye, everyone. Thank you very much for joining us.